Today we're going to be talking about systems of equations with 3 variables and 3 equations. Up to this point in your past, you should have been doing system of equations with 2 variables and 2 equations. So just as a quick review, the methods you would use to solve that are substitution, or adding and subtracting, or linear combination. And you will have to recall how to do these methods in order to solve a system with 3 variables and 3 equations, because you're going to get it down to 2 variables and 2 equations. So first of all, you want to choose any 2 of the 3 equations that you're starting with and eliminate any variable you want. Second of all, choose the remaining equation with one of the previous 2. And here's what's key about it. Eliminate the same variable that you did from the first set. Then, you're going to use your 2 equations and apply any one of these previous 3 methods. Because now you're down to 2 equations and 2 variables. And you're going to get one of 3 possibilities. You're going to get variables that have an answer, or you're going to get no solution. And if you end up with 2 variables and no solution for either one of them, then the whole system has no solution. Or you could end up with infinitely many solutions. If this occurs, what will be different from this compared to algebra 2 is then you will go ahead and rate your answer in terms of one of your variables. So let's take a few minutes now and start solving a system. One last step here. After you get your answer, make sure you substitute it into one of the originals to get all 3. So here's our system. X plus 3y minus z equals negative 11. 2x plus y plus z equals 1. And 5x minus 2y plus 3z equals 21. I'm going to pick the first 2 equations. And the reason I pick those is because if I simply put a plus sign between them, my negative z and my positive z will drop. So I'm just going to rewrite them here. X plus 3y minus z equals negative 11. 2x plus y plus z equals 1. And I said we're simply add down. 3x plus 4y, my z's dropped, which is my purpose, equals negative 10. So I got the first 2 down to 2 variables. So now I have no choice but to pick the last equation and one of the other 2. And since this has the negative, I'm going to pick this one. So now I'm going to do the same thing. Using x plus 3y minus z equals negative 11. And using 5x minus 2y plus 3z equals 21. Here, I eliminated z. So over here, I must also eliminate z. In this equation, I have positive 3z. So to eliminate that, I would need a negative 3z. And I can get that by multiplying the first equation by 3, and I'll get a negative 3z. So if I multiply everything by it, I get 3x plus 9y minus 3z equals negative 33. Now I'm going to plus these, I get 8x plus 7y, my z's cancel again, equals negative 12. Now I have a system of 2 equations and 2 unknowns. So to solve that, I'm going to use linear combination. If I choose to eliminate x, I'm going to multiply this equation by 8 and this one by negative 3. So that I get 24x plus 32y equals negative 80. Negative 24x minus 21y equals positive 36. When I add those, my x's now drop. And I get 11y equals negative 44. So y equals negative 4. But I was searching for more than just y. I also need x and I need z. So I'm going to take this y and plug it into one of these 2 equations. And I'm going to choose the first one. 3x plus 4y. And I got my y value to be negative 4, so I'm going to substitute that in. Equals negative 10. 3x minus 16 equals negative 10. Add 16. 3x equals 6. X equals 2. I have x, I have y, now I need z. And I'm such a creature of habit that I'm just going to pick the first equation and substitute x and y in there. So x, which is 2, plus 3y, which is negative 4, minus z equals negative 11. That's 2 minus 12 minus z equals negative 11. Negative 10 minus z equals negative 11. Add 10. Negative z equals negative 1. So positive z equals 1. So instead of an ordered pair, I'm going to write it as an ordered triple in alphabetical order. X was 2, y was negative 4, and z was 1. And I can always double check my answer by plugging them into the second equation and the third equation to make sure they work. 2 times 2 is 4, minus 4 is 0, plus 1 is 1. 5 times 2 is 10, minus 2 times negative 4 is 8, and plus 8 is 18, plus 3 is 21. So they work. Okay. Ready to try a second one? This time our system is negative x plus 2y plus z equals 3. And 2x plus 2y plus z equals 5. And last, 4x plus 4y plus 2z equals 6. I'm going to choose the first 2 equations. When I see these z's being the same, if I multiply one by a negative 1, the other z's will drop. So I have a negative x plus 2y plus z equals 3. And I'm going to multiply this one by a negative 1. So the negative 2x minus 2y minus z equals negative 5. Now when I plus these, negative 3x, y's drop, z's drop, equals negative 2. X equals 2/3. So now, if I use, I have no choice but to use this last one and one of the other ones. Doesn't matter. I'm going to pick this first 2y plus z equals 3. And 4x plus 4y plus 2z equals 6. I eliminated z, so I'm going to do the same thing again. To do that, I have a positive 2z. To eliminate it, I need a negative 2z. So I have to multiply this top equation by a negative 2. Which gives me positive 2x minus 4y minus 2z equals negative 6. So I get 6x, y's drop, x's drop, equals 0. I get x equals 0. Here I had x equals 2/3. Here I have x equals 0. I can't count them equally different numbers, so there has to be no solution. And in fact, if I chose to say eliminate y instead, I think we would get an answer that didn't make sense. So let's try that. 4x plus 4y plus 2z equals 6. If I eliminate y, I have to multiply that by negative 2, so I would have a 2x. I'd still get x equals 0. So it just shows a contradiction, so there can be no solution. Now let's try 2x plus 3y plus 7 equals negative 3. X minus 6y plus z equals negative 4. And negative x minus 3y plus 8z equals 1. Again, I'm just going to pick the first two. And this time I'm going to eliminate y. So I have 2x plus 3y plus 7z equals negative 3. So eliminate y. This is a negative 6y. So I'm going to have to multiply this 3. I need a positive 6. So this I have to multiply by 2. Which gives me 4x plus 6y plus 14z equals negative 6. So then I have this 5x plus 15z equals negative 10. Now I have no choice but to pick 3. And again, I'm eliminating y's. So I'm also going to pick 1. 2x plus 3y plus 7z equals negative 3. Negative x minus 3y plus 8z equals 1. And when I add this, I get x. Y's are gone again. Plus 15z equals negative 2. When I put these two equations, those two variables together, if I eliminate z, all I would have to do is change these signs, and I can eliminate z. 4x equals negative 8. X equals negative 2. I'm going to stick it in this bottom one. X, which is negative 2, plus 15z equals negative 2. 15z equals 0, so z equals 0. Now I need y. I'm again going to just stick it in the top equation. 2x, which is negative 2, plus 3 times y, which is what I'm looking for, plus 7 times 0 equals negative 3. Negative 4 plus 3y plus 0 equals negative 3. Add 4 minus 1/3. X, -2, y, 1/3, z, 0. And let's try one last one. The system is -2x plus 4y plus z equals 1. 3x minus 3y minus z equals 2. And 5x minus y minus z equals 8. And if I use the first two equations, what variable do you drop? Z, since one is a plus, one is a minus. -2x plus 4y plus z equals 1. 3x minus 3y minus z equals 2. When I simply add them, my z's drop. So I have x plus y equals 3. Then I have to use the bottom one. It's a negative z, so I'm going to choose the top one. This is a positive z. -2x plus 4y plus z equals 1. 5x minus y minus z equals 8. My z's drop. Then I have 3x plus 3y equals 9. When I take that system of two equations and two unknowns and put them together, if I eliminate x, I have to multiply the top one by -3, which will give me -3x, -3y, -9. When I add them, I get 0 equals 0. Is that true or false? It is true. So this is infinitely many solutions. In Algebra 2, you could leave your answer there. In college algebra, you're going to write your answer in terms of x, or y, or z. And I'm going to look at my equations, where I had two variables. I had x and I had y. So I'm going to write my equation in terms of x or y. So if I want to write it in terms of x, first I have x. Then this one will be y's value, and this one will be z's value. So I had x plus y equals 3. I'm now looking for y's value. So I want to solve this equation for y. So I subtract x. And I have y equals 3 minus x. So in the y spot, I'm going to put 3 minus x. Now I'm looking for z. So I'm going to go up here to this first equation. -2x plus 4y. And y is 3 minus x. Plus z equals 1. This time, I'm solving for z. So let's see what happens. -2x plus 12 minus 4x plus z equals 1. -2x, -4x, -6x plus 12 plus z equals 1. Still solving for z. Add 6x and subtract 12. And I get z equals -11 plus 6x. And there's my solution. You should have plenty of time to get started on your assignment from your book.